Hello everyone, I'm Dr. Naresh Kumar, Assistant Professor in the Department of Electrical and Electronics Engineering, Institute of Aeronautical Engineering, Hyderabad. Today we are going to have a discussion on problem solving on DC motor. So first here, the first problem, a field current in DC shunt machine. A field current in DC shunt machine is 2 amperes and the line current is 20 amperes and at 200 volts, and calculate the generated EMF when working as a generator and the torque in Newton meter when running at 1500 RPM as a motor. Take the armature resistance is 0.5 ohms. So first here armature current. So armature current equals to, if you see the diagram first here, this is the DC shunt generator diagram. Now if it is working as a generator, so first here ISH. So here in this, so this is the armature AA, and this is the field FFF, and next this is the load, and this current is shunt field current is 2 amperes, and this line current is 20 amperes. If you apply KVL at this node, IA equals to IL plus ISH. So if you apply KVL, sum of entering currents equals to sum of leaving currents. So now here that is 20 plus 2, that equals to 22 amperes. So now here induced EMF, generated induced EMF EG equals to V plus IARE. If you apply KVL here, so generated EMF equals to V plus IARE. So here V equals to 200 volts and IA equals to 22, sorry, not 822, this is 22 into this RA equals to 0.5. So now the generated EMF equals to 211 volts. Next, second question, the torque in Newton meter. So now here the torque formula. So first to get the torque, we need EB value. Now here in case of DC motor, this is the DC motor diagram. This is line voltage. This is load voltage. Here this is shunt field current is 20 and this line current is 20. And here this IA equals to this 20 minus 2 is 18 amperes. Here 20 plus 2 is 22 for DC generator, and 20 minus 2 is, this is 18 amperes armature current, and EB equals to V minus IARA, that equals to 20, here 18, not 22, 18 and 0.5. So this value is 191 volts. And next case here, this torque equals to actual formula T equals to 0.159 Z into phi into IA into P by A, or another formula is, so output power in watts divided by 2 pi n omega. So now here 2 pi n, that means omega. Here this n equals to n by 60 in the RPM. So now here this is the 191 and IA is 18 amperes and speed is 1500 RPM, and next 2 pi 60. The simplified value is 21.9 ohms. So next second problem, a DC shunt machine connected to 250 volt supply has armature resistance of 0.02 ohms and field resistance of 100 ohms, and find the ratio of speed machine as a generator to the speed as a motor. So the line current in each case is being 80 amperes. So now here ISH equals to 250 by, so now here this shunt field resistance, this one, so thus 250 by 100, that equals to 2.5. So now here armature current equals to, so this is shunt resistance, shunt field winding resistance, here this is 100, and next here this one This one is here ISH is here 2.5, and next here this EG equals to V plus IARA, this is 250, plus this is IA equals to 80 plus 2.5. 80 amperes is here, this is the line current, this is not 80 current, 80 amps current, and this is 2.5. So now this current equals to 82.5, IA equals to 82.5. So now here, so the final induced EMF is EG equals to 259.9. Next, it is working as a motor. So in this case, ISH is same, total voltage divided by 250 volts divided by this 100, that equals 2.5. 80 minus 2.5, that equals 77.5, and EB equals to same thing, 250 minus 18, this one equals to 77.5, that into 0.012. So this is the 0.012 is that is 0.02 is armature resistance, and this is the 240 volts. Now the ratio, this is for next. This one, if one speed is this EG and this is EM, so this is 259 and this is 249, this one divided by this one is the EG is directly proportional to the N. EG equals to Zn pi by 60 into P by A. Next, a shunt generator delivers 50 kilowatts at 250 volts and runs at 400 rpm. The armature resistance and field resistance are 0.02 ohms, 50 ohms respectively. Calculate the speed of the machine running as a motor and taking 50 kilowatts at input at 250. Allow the 1 volt per brush drop for current. Solution for this. So first here. So now here IL equals to in this diagram, in this circuit. So here this is the shunt field winding, this is the armature, and this is the load. So now here this IL equals to total power divided by voltage, and next here this ISH equals to V by RSH, this voltage divided by this 50. And now here in this case, this value is 5 amperes and this value is 200 amperes. Now IA equals to IL plus ISH, that equals to 200 plus 5 equals to 205 amperes. So now here next case, EG equals to V plus IARA plus voltage drops 250 plus this is 250 and 205 this one, and RA is 0.02, and next 2 volts 2 into 1. So this voltage drop, here we have 2 brushes, so 2 into 1. So the final EMF is EG equals to 256. Now if it is a DC motor, so if it is a DC motor, same thing, but here this is 200 and this one is the 5 amperes, and but here it is a plus for DC motor and the DC generator and minus for DC motor, and here minus for DC motor and plus for DC generator, and here this value is 244.1. And next the ratio is EG here 241 divided by 256.1. Now here the calculate the speed of the machine running as a motor and generator, and the ratio here 381.6. A 4-pole DC shunt motor takes 22 amperes from 250 volt supply, and the armature current, armature and field resistance are 50 ohms and 100 ohms. And the armature is lap connected with 200 conductors if flux per pole is 20 amperes. Calculate the speed and gross torque. So here EB equals to Zn pi by 60 into P by A, and EB equals to another formula V minus IA RA, and IA equals to IL minus ISH, and ISH equals to V by RSH. So now here V is this 220 volts and RSH is here 100. So this value is 220 by 100, that is 2.2, and this IL is here 22 amperes and this one is 22, that equals 19.8, and this EB equals to V minus IARE, this is 220 19.8 and this 0.5. So that value is 210 volts. This one is the diagram for shunt generator, and EB equals Zn5 by 60 into P by A. From this you can calculate the speed of the motor. So now here Z5, so phi value is given 20. So for here EB 60 into, so if you separate the speed EB 60A and phi ZP, here Z number of conductors 300 here, sorry 200 conductors, and here number of parallel paths here. What are the parallel paths? Not mentioned. So it takes armature field current, and the lap connected means 4 and 4 P, and this one is A, and this is 20 milliwebers and 210 EB and 60. So now the final value of EB equals to 525.5, and next this torque equals to 1 by 2 pi Z phi 1 by 2 pi Z phi IA into P by A. This one is the torque. So now here are 0.159 Z phi IA into P by A. So here everything is given. IA equals to 19.8 and P, and this is A, and 300 number of conductors, and next 200 number of conductors here, and this is flux, and this torque is 18.99 Newton meter. 18.89 Newton meter. 200 volts lap wound DC shunt motor, 800 conductors, and its armature. On its armature, the resistance of armature winding is 0.5 and field winding resistance is 200 ohms. And the motor takes a current of 21 amperes, flux per pole is 30 milliwebers, and this is the speed and this is the torque. So now here solution for this. Shunt current equals to V by RSH, so that equals to 200 by 200. So this 200 divided by 200 volts divided by 200. So this is the shunt current 1 amperes. And next armature current equals to IA equals to IL minus ISH. So this IL equals to 21 amperes. And next here 1 minus 1, that equals to 20 amperes in case of DC shunt motor. And next EB equals to ZV minus IARA, 200 minus 20 into 0.5, that equals to 190 volts. Next, this one 21 amperes and 1 amperes. If you apply KCL at this node, here is the 20 amperes. 20 plus 1 equals to 21. And next here this 200 volts by 200 means that is 1 amperes here. Next case here EB equals to Zn5 by 16 to P by A. Same thing in the previous problem we discussed the same type of problem. So now N equals to EB 60 into A by Z 5 Z and P. Here Z is 800 number of conductors here, and next it is a lap connected. Here where is it mentioned? Here it is a lap connected. So has lap connected, and this A equals to P and P 4 number of poles here. So how many number of poles here? So 4 number of poles in this. So what are the poles? 4 number of poles. And next here this is 30 milliwebers. 30 milliwebers. And next the speed is 475. So 475. Now here. So now here same thing here you find out torque equation. T equals to 0.159 Z phi Ia into P by A. Here 0.159, that is 1 by 2 pi. So if you substitute in this, you will get the torque value 76.32 Newton meter. And next case, a 220 volts series motor is taking a current of 20 amperes. The resistance of armature is 0.5 ohms and the resistance of series field winding is 0.25. So calculate the voltage at brushes, back EMF, power wasted in the armature and power wasted in the field. So this question is important. So first here, voltage at brushes. So what is the voltage at brushes here? EB equals to V minus IARA. So now here V equals to 200 volts and here IA equals to 40 and armature resistance is 0.5. That value equals to 210 volts. And what about the back EMF? That back EMF equals to V220 minus IARA plus RS. So this RA value is 0.25 and this RS value is 0.5. So this is 0.25 series field winding. So now here this one, here this diagram should be like this. Here this is the armature winding and this one is the field winding and here is the supply. So now here this value is back EMF equals to 190 volts and power wasted in the armature, that equals to I square into RA. This RA value is 0.5 and this IA equals to 40 amperes. Here in case of series DC motor, series DC motor, IA equals to line current, armature current equals to line current equals to field current, I series current. That means I field, IF. And next here, so that value is 800 watts. And next, power wasted in the field winding. Here I square, same current flows to the each element in case of series circuit. In the series current and armature current and field current are both are same. So now here RA is 0.025. This is not RA, RF. So this is field. So now here that value is power wasted in this is what is the value here? 400 volts for watts. So next case, if a 6-pole lap connected DC motor with 864 conductors takes a current of 110 amperes at 480 volts and the armature resistance and field resistance of 0.818 and 0.02 respectively. The flux per pole is 50 milliwebers and calculate the speed and gross torque. So now here EB equals to V minus IARA. This is series winding. So here armature current and series current is same. So that equals V minus IARA plus RSS. This is series field current. So this is 480. So 480 and this IA equals to and 110 amperes and next RA. So these two are. So this one is RA and one is R series. And if substitute in this, that is back EMF equals to EB equals to 458. And next case, this is the series circuit diagram, R series and RA. And this is IL, same current, so 110 amperes here. This is 480. If you apply KVL in this, so this is the formula, EB equals to 458 volts. And next case, we need the speed. So how we will calculate the speed from the back EMF? This back EMF is 258 and from this you calculate the N. So N equals to, and EB equals to, substitute in this, and next A is equal to number of parallel paths. It is a lap connected and P equals to 6 and A equals to P equals to 6. And next 50 milliwebers and this is the flux and Z 864 number of conductors here. So what are the conductors here? How many number of conductors? 864. So now this speed is 636 rpm, rotations per minute. And what about this? So same time here, power is eb into ia. So this eb into, what about ia value? Ia equals to same 110, this one, and this is the power output. And next, torque equals to same thing, 1 by 2 pi z phi ia into p by a, that is the torque formula, or 0.159 z phi ia into p by a. Here you can substitute everything. So from this you can, so now the torque value is here 7560.3. Next, a 4-pole 230 volts DC series wave connected armature with 1254 conductors with flux per pole of 22 milliwebers and takes 50 amperes for motoring. The armature and series field coil resistance are 0.3 and 0.2 respectively. Calculate the speed and torque developed in watts. Same thing, same procedure for this one is also. First, E equals to V minus IARA plus IA into R series. So 230 volts V, and IA equals to, what is the IA value? IA value equals to, IA value is given 50 amperes. So here 50 amperes, and RA and R series 0.3 and 0.2, this one, and that value EB equals to 255 volts. And what about the speed? How we will calculate that speed? From the back EMF formula, EB equals to Zn5 by 60 into P by A. Now here Z is total number of conductor 1254, and N you need to calculate. P is total number of poles P, and wave connected. Here A equals to 2. Here A equals to 2. You can substitute A equals to 2 here. This is A equal, this is P, and this is A. And now here to Z is this one, and this is the flux 22 milliwebers. And from this, this is calculated to 55, this one EB, and from this the speed value is 277 rpm. And next, torque equals same thing, 1 by 2 pi, that value is 0.159 phi IAZ into P by A. Now this value is 0.159, this is flux, this is armature current, the total number of conductors, and P, and this is A, that torque equals to 438.6 Newton meter. A 4-pole P equals to 4, and motor is fed at 440 volts and takes armature current 50 amperes. The resistance of armature circuit is 0.8. The armature winding is wave connected, A equals to 2 with 88 conductor, 888 conductors, and useful flux is 0.023. And calculate the back EMF and speed. Same procedure. This one is also series motor. So EB equals to V minus IA RA plus RC. So this complete value, armature circuit value is RA plus R series is 0.028, and this armature current is 50 amperes, and this voltage is 440 volts, and this one equals to 426. EB equals to, same thing, from the EB calculate the speed. So now here P equals to 4 and A equals to, so here it is a lap connected or wave connected. It is a lap connected circuit. So winding, so it is fed at armature, and the resistance of this one 88 wave connected. A equals to 2 here, not 4, and this 426 is this one EB, and this triplet are the 888, that is Z, and this one is a flux. So in this the speed value is 1251.46. And next here A 4-pole 230 volts DC series wave connected armature with 1254 conductor with useful flux. This one 22 milliwebers, 50 amperes motoring, and the armature winding, this one is 0. Armature winding resistance and field winding resistance, and calculate the speed. So this one we already discussed in the previous slide. So now EB equals to V with 230 volts, and this is 50, and this one is 0.3 and 0.2, 0.3 and 0.2. 50 is the armature current and 230 volts. And next EB equals to, from the EB value is 205. So from the EB you calculate the N value. So here this N value 1254, here are the conductors and 4 are the number of poles, and it is a wave connected. This one is 2, and this is the flux. So now speed is here 223 rpm. So now here torque equals to 1 by 2 pi z5, 1 by 2 pi z5 ia into p by a. So T equals to 1 by 2 pi. So now here if you substitute in this all the parameters in this equation, that is 997.9 Newton meter. And a 4-pole DC shunt motor takes 22 amperes from 220 volts supply. The armature and field resistance are 0.5 ohms and 100 ohms 100 ohms respectively. The flux, the armature is lap connected with 300 conductors, and flux is this one. Same procedure, only numericals are changing. So EB equals to V minus IARE. Here this is V 220 volts, and IA equals to 22, and RA equals to 0.5. And next here from the EB, here EB equals to 209, and Z equals to here 300 number of conductors, and here flux value is 20 milliwebers, and number of poles P, and it is lap connected here this one, and the speed is 2090 rpm. Now this torque equation formula 1 by 2 pi z and z5 ia into p by a, so that value equals to 21 Newton meter. I hope all these problems are clear to you. If still have any doubts in this lecture, you can comment in the comment section below. I will answer to your queries. Thank you very much to you.
Like, share and subscribe. Hit the bell icon for more updates.